Hi everyone. In my today's session, I'm going to cover one of the fundamental low-level design principles, collectively called as SOLID. Okay. So SOLID is a set of design principle that plays a very important role during object-oriented design of software products, or I can say enterprise-grade software products. Software development becomes easy, reusable, flexible, and maintainable when we use these design principles. So basically, if we are not following these solid design principles, then we will end up with a lot of hurdles or issues. Okay. And without following these solid design principles, a software application development itself is incomplete. Okay. So we must be adhere to these design principles and we must make use of them in our day by day developments. Okay. So solid principles, as I said, they have changed the development approach and dominated in software development industries. Okay, nowadays, almost each and every organization is following the solid principles in their day-by-day development. Okay, so what are the advantages of solid principles basically if we use them? Okay. So, uh, the regular application of these principles make software source code and design more understandable, flexible, and maintainable. Concentrate on these three words, guys: understandable, flexible, and maintainable. First of all, by making use of these principles, you will not end up with a spaghetti code. I hope you understand what is the notion of spaghetti code. Okay, you are basically mixing the things into one flat file or into a couple of or a bunch of modules, and basically it is always difficult for you to understand for what purpose you had did some change and if you want to implement new change. Okay, so by making use of these principles, first of all, your source code will become understandable. It's like a poetry. Okay, it's like a stanzas in your poem. Okay, so very simple, very easy to understand, small insights. Okay, flexible. Why flexible? Because once your classes or modules are simple and understandable, they are flexible to use or to further extend it. Okay, and they are maintainable because of this cleaner approach. Okay, you can maintain the source code which grows in scale very easily. Okay, so these principles also help us in creating loosely coupled implementations. Okay, so I hope you understand the concept of coupling and cohesion. Okay, a system is called a loosely coupled implementation when two modules or two classes doesn't have hard-coded references to each other. Okay, they basically communicate or they basically make use of one other in such a way that they will never depend on each other in a hard-coded fashion. So using these principles allow us to create loosely coupled systems or implementations. Development team members can work parallelly on various parts of the application or requirements. Agreed? Because as there are no tightly coupled implementations or modules or classes in your system, if this has been achieved, then development team can very easily work on independent modules or classes of your application because they are not dependent on each other. There is no threat that if one developer makes some change that will have affect another developer. No, they are basically independent in nature. So this will allow us to achieve parallel development basically. Due to the fact that the classes become smaller and cleaner like poems, the developer can achieve the unit testing coverage of a class to 95% and above. Okay, but I have recorded a coverage of 100% whenever I have done the development. So yes, it's up to you. You can reach to that level also. Okay, because as I said, they are very smaller and cleaner, so you can very easily achieve a coverage of 100%. In one of my previous video, I have already explained the notion of unit testing and the significance of coverage. Okay, you can refer that. Now, enterprise grade systems our scaling systems become complex and difficult to maintain. It is agreed because more and more requirements will keep on coming, more and more features are added over the period of time, so that's why they become very complex. So these principles help us to create a maintainable system, and a maintainable system is the desired aspect of an enterprise grade software products. Okay, however the big your application or your software product is, okay, if you have followed these approaches, the source code should be in such a format that it can be easily maintainable in the sense you can add new features easily. If you don't want some features, you can remove them easily, you can ensure the quality. All these aspects will come as part of maintenance. Okay, now let's go through what are these principles now actually. Okay, we understood what are solid principles, why we use them, what are their advantages. Now actually what these principles are. Now each and every letter or character of solid word represents these principles. Like S is meant for single responsibility principle. Now what does that say? A class has one job to do. Each change in requirements can be done by changing just one class. Look at the beauty of this statement. A class has one job to do. Okay, for example, if I say I have written a class called email service, then that class should do only email related operations or functionalities. It should not do something related to a user registration or login. Okay, so that's why they say, okay, a class has one job to do, that's it. And if it is going to change, it is the only reason, because of that class's functionality or requirement changed, only for that reason it will change. Okay, so do remember this. Now next principle, open close principle. Class is happy, that is open to be used by others. Class is not happy to be changed by others. Okay, this is what the open close principle says. Okay, um, you can extend the existing functionalities, but you should not change the existing classes. That's what the open close principle says. So whenever you implement a new functionality, it should be put into a class. Okay, and if you want to extend that functionality by further, then you have to extend the existing functionality. Okay, and sorry, existing class, and create the new functionalities based on that. Okay, that's why it says a class is happy to be used by others. A class is not happy to be changed by others. Okay, basically a class is open for extension, but it is closed for the modification. Okay, so do understand this concept. One class should represent only one responsibility. Okay, now comes Lisco's substitution principle. A class can be replaced by any of its children. Children classes inherit parents' behaviors. Okay, so basically what this principle says is, okay, the object references of base class are basically used to hold the object references of their derived classes. Okay, the derived class objects can be replaceable. Okay, sorry, the base class object references can be replaceable by their derived class objects. So that's what Lisco substitution principles say. Okay, and then interface segregation principle. When classes promise each other something, they should separate these promises into many small promises. Here promise means a interface. Okay, in object oriented programming, so it's easier to understand. Okay, so basically instead of creating one big fat interface which contains all the functionalities, we have to divide such fat big interface into smaller interface, so that we should not force any of our clients to implement or classes to implement all the interfaces which they don't want. So that's what interface segregation principle says here. Dependency inversion principle. When classes talk to each other in a very specific way, they both depend on each other to never change. Okay, instead classes should use promises, that is interfaces and parents, so classes can change as long as they keep the promise. Okay, so what dependency inversion principle says, that it's a very simple English I have made use of here. So what it says is, when classes talk to each other, okay, in a very specific way, they basically depend on each other. They will, and they expect the other to never change. That means if there are two classes A and B, and if both depend on each other, A to B, B to A, it's difficult to extend the functionality of both of these classes because they are hard coded to each other, they are coupled. Okay, now what dependency inversion principle says that one should depend on abstractions but not on implementations. Okay, so what is that abstraction? The abstraction is nothing but an interface or a contract. Okay, so you should always depend on this abstraction, not on the implementation. Okay, your implementation should adjust to the abstractions or the interfaces or the contracts or the promises, but not the promises on the actual implementation. Okay, so one such example for this is the repository pattern. Okay, so you basically specify a repository's contract using some I repository of some generic class. So you will specify the standard operations in that contract like add, remove, update, delete, insert, like that. Okay, so basically this is the contract that each and every class should implement, and how internally it implements, it's up to the implementation. Okay, the contract says that you have to provide all these four operations. So what the repository pattern says is the repository pattern will basically implement or act as a repository. The underlying storage can be anything. Okay, it may be a SQL Server DB, it may be a flat file, it may be anything. Okay, but repository will return you data as per the contract you have mentioned in that particular interface. Okay, so that's it from these definitions. Okay, so now let's come to the consequences. What will happen if we don't follow these principles? Okay, first, the software product will eventually enter a state where it's no more testable, gone. When a software product enters this state, then it is very difficult to maintain and do enhancements or do any kind of bug fixes. Okay, because you are not able to ensure the quality of your product. Only fixing one bug will create another bug or an unknown issue. Okay, so whenever a system has entered this state, this is a very known scenario or a very familiar scenario that I have seen in my career. Okay, one developer will fix one bug. Okay, but it will result in creating one more bug because it is not tested itself. Okay, if he would have implemented some unit test, the moment he adds new changes or introduces the regression, it should have shown him directly in terms of a unit test runs, basically the unit test passing cases. But if he is not able to test, then yes, he is creating new bugs by fixing a new bug or implementing a new user story. Okay, then in most of the cases, fixing an issue in such products will lead to creating new issues or regression, as I have already explained. Okay, the product source code will end up with a tight coupling of the code with many other modules. So you will end up with the resulting hard coded references to other modules or other classes basically in your software source code. This will lead to increased development effort for developing new requirements and bug fixes. Also, most of your time will be spent in understanding the various dependencies caused by this kind of spaghetti code or tightly coupled code. So basically you have to go through each and everything. If you fix something and if something else breaks, you have to correct it. So this is how you will spend more time when you try to do something. The dev teams will start duplicating the same piece of code which could have reused. Yes, this will happen because what happens basically, if you are not basically keeping reusable software components or services into one place as a library, okay, or into, let's go to the granularity level of class, if you are not putting them into one class which is dedicated for a single piece of functionality, then what happens basically, developer will start copy pasting such code wherever he finds in his source code, and he will keep on duplicating the same piece of code. And due to some reason, if that piece of code changed to support something else, then wherever that piece of code is used, we have to correct it. And if we do to miss that, or if we miss to do that, yes, again we are creating the bugs. So basically the level of frustration we reach is something like this. Okay, so I hope you people understood the significance of following this low level design, or I can say solid principles. Okay. This will definitely help us to get a purified design, basically a very detailed design. Okay. And what is the best part, and when this needs to be done, basically the moment you receive a new user story in your sprint, okay, dedicate the first 2 days for this. Okay, go through your application source code, okay, go through your existing functionalities, go through your new functionalities, perform a detailed design, and then start following the solid principle to create the new classes. Okay, so once this is done and documented properly in a design document or a low level design document, the rest of the sprint, that design document will act as a single source of truth for your further development. Okay, so I hope you understood the notion of the solid principles and its introduction. We will go through one by one principles in my next video, and yeah, we can have a detailed look at them. Thank you for listening and have a nice day.